Hey everyone, this video is going to look at GCF factoring. What we're going to do first is we're just going to remember what GCF is, and we're going to talk about factoring, and then we're going to go through examples that cover most of the major ways that you can see GCF factoring, including one that has a set of extra factoring involved. And I'm going to try to show you a couple of different ways to find the GCF, including when we get to some larger numbers, I will show you a way to build a table in Desmos that maybe can help you deal with some of the factoring. So first, let's just take a look at what GCF is. We're talking about GCF. So that is the greatest common factor. Remember that factoring is simply a form of division where you are trying to break something down. For example, if we take the number 12, it can be broken down into 2 times 6, or it can be 3 times 4, or it could be 1 times 12. These are all factor pairs, two items that multiply to give you 12. So what we're doing is, what if we have several numbers? For example, what if we have 12 and we have, let's say, 8? Well, 8 could be broken into, 1 times 8 and 2 times 4. So I'm looking for, if I want to find common factors, that's just numbers that both of them have. Well, they both happen to have a 2. They both happen to have a 4. They both happen to have 1. And that's it. If you notice, the other numbers are only in one or the other. Well, ones can automatically be crossed out. If they're the only thing, then factoring doesn't happen. If it's only a 1, then remember we call that prime. But when there's more than one item, we have 2 and we have 4. These are common factors. So we have 2 and 4. Now we want the greatest commons. We want the largest out of them that goes into both. So in this case, the GCF would be the 4, because that's the largest that goes into 8 and 12. Now let's look at this with variables involved as well. So the first thing is, there's sort of two things that we always look for. The first thing we look at is, I like to look at the variable first. It's the easiest to spot. And then we also look at the numbers. Remember, the numbers are broken into two categories. You have the coefficients, and you have any constants. Remember, coefficients are in front of a variable. Constant has no variable. These are the two things that we always look at and examine. So first, let's look at the variables. Now, when I look at these, and let me sort of switch colors here, I have 4 terms. So I look at the 4 terms, and I look to see, do they all have a variable? And in this case, that is a no. They do not all have a variable, so for this problem, variable doesn't matter. Numbers will always matter. They will always be there, even if it's just a 1. So now I look at those same terms, and what I'm going to do is I'm going to make a little division underneath each one. I need to figure out what numbers. Now I treat coefficients and constants as if they're the same. So what I'm going to do is, I see that I have 15s and 10s when I look at my coefficients and constants. So I'm going to make a little table. I'm going to have 10 and 15. So I just need to start looking at what goes into them. 10 has the numbers. It's sort of like what we did before. I'm going to make a list of all the factors. Numbers that go into 10 are 1, 2, 5, and 10. 15 has 1, 3, 5, and 15. So when I look at these, what do they have in common? Well, other than 1, which remember I don't really care about, I have 5s. So that's your GCF right there. So what I'm going to do is I'm going to write that in the denominator. 5, 5, 5, and 5. Now all I have to do is divide. I'm first, though, going to write down that 5. That's my GCF, and I'm going to open a parenthesis. So 15 divided by 5 is 3, and drop the x cubed and the plus. I tend to ignore all the signs and just fill them in their spots in the answer. 10 over 5 is 2, x squared. Bring the minus down. 15 over 5 is 3x. Bring the minus. 15 over 5 is 3. And there is our factored form. That's our answer. If we distributed this back, we would end up with the original problem. Okay, let's look at this one. Again, I'm going to first view the variables, and then I'm going to view the numbers. So I have a to the 7th minus 2a to the 5th plus a to the 4th minus 3a to the 3rd. Remember, there are invisible ones in front of these. So first I look at the variables. Do I have any variables in common? Yes, I do. They all have an a value. So that means I need to remove an a. And remember that what we do is we're going to remove the lowest power. So we're going to look at which power of a is the lowest. Now remember, if you don't see a power, it's a power of 1. But notice my lowest power is right here with an a cubed. So I'm going to say a cubed, a cubed, a cubed, a cubed. Now I look at my numbers. When I look at the numbers, I have 1, 2, and 3. So 1, 2, 3. Well, 1 only has 1 in it, 2 has 1 and 2, 3 has 1, 2, and 3. But I need something, and these spaces wouldn't be filled with anything, that they all three have in common. Well, that's only right there. That's a 1. So I'm not going to pull a number out. If you want to write 1 down, if you want to write 1, 1, 1, 1, that's fine. That's up to you. But my GCF is a to the 3rd. Now I divide, and then remember, when you have powers, you subtract. So we have a to the 7 minus 3, which is 4, minus 2 over 1 is 2, a, 5 minus 3 is 2, plus, that's an a, 4 minus 3 is 1, so I don't put a variable, or a power, sorry. And then 3 divided by 1 is 3. The a's are the same, so they simply cancel away. You don't write a to the 0 power. So here is our factored form. Okay, so we looked at one where it had just a number GCF and one where it had a variable GCF. So let's look at this next one. So again, I am looking at the variables, and then I'm looking at the numbers. Let me sort of separate that away. So again, I have 8x to the third minus 12x squared plus 8x. So I first look at, and I'm going to put some division signs here. Do they all have a variable? And yes, so I'm looking at the lowest power, which happens to be right here with a 1. So I'm going to put an x, and an x. Now I look at my numbers. So I have 8 and 12. I have another 8, but I only care about it once. So 8 and 12. Well, 8 has 1, 2, 4, and 8. 12 is 1, 2, 3, 4, 6. Again, don't need that, and 12. So what do they have in common? Well, they have the 1s, but the minute I get something else, that no longer counts. 2s, there is a set of 4s, so the 2s no longer count. So 4 is my GCF. So I'm going to drop a 4, a 4, and a 4. So my GCF is 4x. Now remember, there's little invisible 1s here. So now I'm going to be, and actually let me put that in the right color for you. So 4x. So 8 over 4 is 2x. Subtract, and I get a 2, minus 12 over 4 is 3. X, subtract, that's a 1, so I don't put anything, plus 8 over 4 is 2. X's are the same, so they're gone. So there is my factored form. Now, the question that always comes up is, well, is this fully factored? Whenever you see a power left, and it's a single variable like this, you always got to check to see, well, could this be factored more? Could this quadratic that's left be split up again? And in this case, that's a no. It can't be factored again. It's at this point fully factored. So that is our final answer there. Let's look at another one here. So again, I am looking at variable and numbers. Let me sort of split the screen up for you. Okay, so when we look at our terms, we have 6y to the 7th minus 6y to the 4th plus 3y to the 3rd. So first I look at the variables. Yes, they all have a y in them. So again, I need the lowest power. So the lowest power is a cubed. It's not always on the end, but if you arrange everything in order properly, it will be. So I'm going to have a y to the 3rd, y to the 3rd, y to the 3rd. Now I'm going to look at the numbers. So 6, 6, and 3. So 3 and 6. Well, that's 1 and 3. That's 1, 2, 3, and 6. So I have empty spaces. So I have 1s and I have 3s. So 3 is my GCF. So I'm going to drop a 3 down. So now I know I have, when I write it on the outside, I have 3y to the 3rd. 6 over 3, is a 2. Subtract 7 minus 3 is going to end up being a 4 minus 6 over 3 is a 2. 4 minus 3 is 1 plus. Now we have a problem. 3 over 3 and y cubed over y cubed fully cancel. Well, we still have to put a 1 down. That's not optional. If there are 3 terms in the original, there must be 3 terms in the answer. If you think of it as 3 over 3 is 1, and then the y's cancel, then you're probably not going to ever mistake that. Let me clean up the 1 there. So here is our factored form. Again, we have a power here. Can I factor that more? At this stage, no. So that's as far as we need to go. Now let's look at a larger problem. Let's see what happens with this problem here. Now this has more than one variable. So again, we're looking at variables and then numbers. So first on my variables, let's identify our terms. 24x to the 6th y to the 5th minus 48x to the 5th y to the 4th plus 120 x to the 8th y to the 2nd. So I do have variables in common. In fact, all of them have an x and a y. So that means I'm going to have 2 variables in the bottom. I'm going to have x and y. I just need to figure out their powers. Well, the smallest x is right here. So that's an x to the 5th. Again, it's not always on the end. The smallest y happens to be here on the end. So that's a 2, a power of 2. Now, we need to figure out the numbers, 24, 48, and 120. You can build the table like I was doing before. So again, remember with variables, we're dealing with lowest power. Now I'm going to flip screens here and I'm going to show you Desmos. I'm going to show you how to build the table there. So what we're going to do is we're going to hit the little plus key and make a table. Now, I am going to, in the X column, I'm going to type in numbers to try. So I'm going to use the online keyboard. So that's a 1, and then enter, 2, 3, 4, 5, 6, 7, and 8. Let's just go to 8 for now. And then I'm going to scroll back up. Now, the first number that we're testing is, you sort of have to put in things where you start. So our first number in there was a 24. So I'm going to say 24 divided by my first column. My first column is actually called X1. Notice the title. You have to have the little 1. If you don't, it will not work. Now my next number happens to be, let's see here, it was a 48 divided by X1. Then the third one happened to be 120 divided by X1. Now, I don't really care about the graphing side of things. That doesn't really matter. So I'm actually going to stretch this over, maybe give my table looking a bit better. Now, what you should notice is I'm looking for patterns on here. I want to see the different numbers, and I'm looking for the same number in all 3 columns. So I have 24. I see a 24 in all 3 columns. I'm looking to see, is there something larger than that? I see a 24 in the top of the 24 column. It's in the second space of the 48, and it's down, let's see, 1, 2, 3, 4, fifth space of the 1/20th of the last column. I don't see anything above any of those that they have in common. In fact, the 24 in the first column is sort of it. So 24 is our GCF. We can see how many times it goes in. It goes in to the first column once, the second column twice, and the last column 5 times. So that's our division right there. So if I flip back to our first tab, I'm now going to fill in my numbers. We know that we're going to have 24. I'm going to show you another way to do this in a moment. So that gives us, we just do our division now. So 24 over 24 is 1. Now remember, I have 24 x to the fifth, y to the second. That's on the outside. So then I have 1, and then remember, subtract your powers. So 6 minus 5 and 5 minus 2. So that's x, y to the third, minus 48 over 24 is 2. The x's are the same, so they're gone. The y's become y to the second, plus 120 by 24 is 5. X, 8 minus 5 is 3. And then the y's are the same, so they're gone. So this is our factored form. Now remember, if you struggle in using the table, there is an alternate method. What I'm going to do is on this next slide, I'm going to write down the equation again. We had 24 x to the 6th, y to the 5th, minus 48 x to the 5th, y to the 4th, plus 120 x to the 8th, y to the 2nd. Now, the other method you can use are factor trees. What I'm going to do is I'm going to break each of these numbers apart. I'm going to make a factor tree. Well, what multiplies to 24? Well, I'm going to go with 4 and 6. You could go 8 and 3, 2 and 12. That's fine. And then 4 becomes 2 and 2. 6 becomes 2 and 3. Well, now I circle prime numbers. That's what you need to work with on factor trees, are prime numbers. Only the circled items matter. So now let's break apart 48. Well, I see a 4 in there, and that's at 12 times. So that's 2 and 2. I can say 3 and 4, and 4 becomes 2 and 2. So I just break every number down as far as it goes. Now 120. Well, I see that, and I immediately see the 0, so I say this is 12 and 10, which 12 we could say 2 and 6, which is 2 and 3, and 10 is 2 and 5. Again, how you break it down comes down to what numbers you think of first. So now the factor tree method says, okay, let's write these numbers, these prime numbers, and let me stick with red with that. And I'm going to write each term separately as prime factorization. That means as a multiply. So for this one, I have 2 times 2 times 2 times 3 times 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Now for the next one, I have 2, 2, 2, 2, and 3. Do put them in order. 2, 2, 2, 2, 3, and then let's see, 1, 2, 3, 4, 5, 1, 2, 3, 4. I just list each variable the amount of times the power says. Then the last one we have, let's see here, we have 2, 2, 2, 3, and 5. 2, 2, 2, 3, 5. And let's see, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2. Now, we need to circle from all three rows when they have something in common. Well, I see a set of 2's. I see another set of 2's. I see another set of 2's. Then I see a set of 3's. Then I see, let's see, we have a set of x's, another set of x's, another set of x's, another set of x's. I'm just going to go till I run out of that variable. No more x's in the middle, so I can't circle anymore there. For the y's, I'm just going to go to the edge here. It doesn't matter. I have a set of y's. I can see that there is another set of y's. And that's it. I ran out of y's on the bottom. So my GCF is 2, 2, 2, 3, x, 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 y, y. So if I put them back together, that is 2 times 2 is 4, times 2 is 8, times 3 is 24. Then I put these together. Let me do that again with this box. That's 1, 2, 3, 4, 5, x to the 5th, y to the 2nd. So there's my GCF. Now all I have to do is look at what's left in each line. Notice all the numbers in the first line got crossed out, got used. These x's are gone, so we're left with an x and these y's. So that is x, y to the 3rd. Now I move to the next line. These 2's and 3, so there's still a 2. These x's are gone, but these y's on the end are gone. So that is a minus 2 x, let's see, no x's, so y squared. Then I put the plus, I'm just using the symbols up top. So these 2's are gone, and so is that 3. These x's are gone, there's still that 5. These x's here, the y's are gone. So that's 5x to the 3rd, which if you remember, that's what we had on the last slide. Factoring out this way does take up more space, but it's your fallback. So hopefully this will help you with remembering how some of the GCF works. We will look in future videos at other forms of factoring, just so that you remember those. But remember, always look for the GCF first before any other factoring. There's only a few exceptions to that. And remember, watch this video as many times as you need, and hopefully it will help you.